through there. I really like that view. There are times you come here where there's just birds everywhere. The right time of year. I'm Peter Dalhouse. I'm a geologist. I'm a research fellow at Federation University Australia. Well, the good thing about geology is that you do a lot of field work. And field work's really how we get our data.
Yeah, it should be right.
Is that enough? You know, there's an old saying in doing field work that there's only two sorts of days. There's good days and there's great days, and today's a great day. Slide the lid off. So geology is the science of the earth. That's how it's made and how it works. And the bit that I look after, the bit that I deal with, is about rotten rocks and wet rocks, soil and groundwater. This is LCC4. And they're the two things that are absolutely vital for all life on Earth. Groundwater is one of those things that you can't see. You can't stick your head in the ground to look at it. And so when you're dealing with groundwater, you know, it's surrounded by lots of myths. You know, people think you need forked sticks or bent wire to find it. But really the only way that you can access groundwater is by drilling a bore and collecting data. And that's why data is so vitally important to managing all of Australia's groundwater resource. Groundwater data has been collected in Victoria for over 130 years. And originally there was a single database, but now that database has been fragmented and split into various government departments. And so just going around to collect all that data meant that you had to go to a lot of different places to get it. So then eventually I had a clever honours student who put together a groundwater database for just part of Victoria, for the Corangamite region in southwest Victoria, and he linked that to a GIS, and this was fantastic. It worked really, really well, but the trouble was I couldn't share that with any other researchers.
There's less in here, I guess.
Yeah, that's right. Yeah, precisely right. So then I took the problem to Helen Thompson and Andrew McLeod at the Centre for E-Commerce and Communications at the uni, or the CECC. And together we came up with the idea of a web-based GIS to put that particular groundwater data set onto the web. And it really opened up an opportunity for them to be able to get into spatial research and visualisation.
Yeah, so it actually does get quite a way in.
Visualising Victoria's groundwater brings together comprehensive information in a way that's decision useful for a range of stakeholders, whether they're water managers, farmers, researchers, catchment management authorities.
It's called federating groundwater data, and that's done on the fly. It's done dynamically, and it just brings together all of that groundwater data for all of Victoria into a single web portal.
Spatially representing information is really effective because people tend to zone in on the place that they're interested in, whether it's my farm or my local government area or you know, the whole of Victoria.
So I'd essentially describe it as it's a web-based map, similar to Google Maps, I guess, for people who are familiar with that, that brings together data about groundwater from various sources. We call it interoperably, but essentially we don't manage any data, we federate that data so that you can get to it in one place.
You could have a data set that's in Melbourne, you could have another one that's in Bendigo, you could have one in Ballarat, you could have them on different computers, on different systems, but you can pull all this data together through common language, through open source standards and through open source software. And the beauty of interoperability is that you can then start linking data together so that you can click on a bore and you might have data coming in from one data set, for example from a state government data set, but you could then connect that same bore to the record in the State Library of Victoria or to a chemistry record sheet that might be at a university or a photograph that might be somewhere else and so on. So you've got this one-click solution to get all of this data that you didn't even know existed. It's just fantastic.
So here we've got an irrigator's bore, and this bore is used to irrigate potato crops in this area. This bore is about 120 metres. I'm a senior hydrogeologist with Goulburn-murray Water, and Goulburn-murray Water is a rural water authority in northern Victoria, and we're responsible for licensing of water in northern Victoria and the licensing of groundwater. Goulburn-murray Water was a partner in the development of the VVG, and we provided in-kind support to the development of it. We use the VVG as a communication tool with our customers, so we can refer our customers to the VVG to get information on the aquifers, where they are, how deep they might need to drill, and how the groundwater levels respond in their area, what the groundwater quality might be. And they can take that information and make some informed decisions about where they might install a bore before making a financial commitment to actually drill.
The department has been involved in really being one of the main sponsors for the project because it's part of a broader initiative to make use of broadband capability. And so our role in it, because it's a groundwater domain of interest, is we provide a lot of information and data to do with groundwater, but also it's a bit of a testing ground as to where we can go with technology and give some direction as to what are the possibilities for us, thinking about how to make that information more available and usable. VVG is the only place that you can, for example, go and see the difference between the groundwater data sets that are collected by two different areas of government. And that in itself has a lot of advantages, and it helps improve the quality of information, and it also means that people, because we're talking about, in this particular case, a discipline which is based on interpretation, that means that more information can only ever be good.
Yeah, sometimes it doesn't happen.
The VVG is a big online repository where we can immediately go home, upload the data that we collect out in the field, whether it be manual measurement or the automated data loggers, put that straight into the VVG system, and then you can bring up this site just by finding it on a map or using the coordinates, and straight away see that data that we've uploaded from our fieldwork.
When we first started this project, we felt like we were just such small fish in this big pond of people that were doing this. And, you know, they had massive budgets. We're talking about CSIRO and others in this case here. And we just felt that we were, you know, well out of our depth. We just felt we were quite out of our depth with it. We persevered essentially because what we were doing was quite different to what they were doing. We persevered because we were putting together all of the data just for research purposes. And so, you know, it worked quite well. And what we found was that when we got into this world of interoperability and started pulling these databases together, in actual fact, you know, we were doing something that other people hadn't done. It became apparent that you could use the same technique to actually pull together any data. So we've been pulling it together for things like fire management planning, for sports and recreation, for agriculture, and so on. What's next? Oh, well, what's next is yeah, I have great dreams. I really do have great dreams for where the VVG is going next, because the thing is, once you federate all this data together, once you've got all of this data together that you didn't never know that was there, you can then start making new discoveries in the data. So there's two aspects to this research that's really good. One is the actual doing it, which is all about the open standards and open source stuff, and, you know, groundwater markup language and things that bring together data. And the second part of it is really the discoveries within the data itself. And those discoveries within the data itself happen because essentially you're pulling together these big data sets and comparing things that people never did beforehand. And so you can then start making new discoveries.